Welcome back, everyone, to the deep dive. We've got a pretty fascinating paper to dig into today. It's all about tackling a challenge with those large language models everyone's talking about, the ones that need massive amounts of data and computing power to train.
Yeah, that's right. And to handle that kind of workload, we often rely on something called distributed training, which basically means spreading the training process across a bunch of computers. But there's a catch.
Let me guess, it needs super fast connections between all those computers.
You got it. Those super fast connections can get really expensive and tricky to set up, especially when you're talking about coordinating like thousands of computers.
Yeah, that sounds like a logistical nightmare. But hold on, isn't that what this paper is all about? The one we're deep diving into today? Streaming DiLoCo with overlapping communication towards a distributed free lunch. It sounds promising, but also kind of complicated.
It is, but it's also super cool. So the paper proposes this idea called DiLoCo, which stands for Distributed Low Communication Training.
Okay, DiLoCo, low communication. I'm intrigued. Tell me more.
So instead of having all those computers constantly talking to each other, DiLoCo groups them into these workers. And these workers train independently for a little while, and then they synchronize their learnings, but less frequently.
Okay, I think I'm starting to get it. It's like having separate teams working on different parts of a puzzle, and they only come together every now and then to see how the pieces fit.
Precisely. That's a great analogy. And by reducing the need for all that constant back and forth, we can ease the strain on those super fast connections.
That makes sense. But there's got to be a but here, right?
Well, even with less frequent synchronization, you still need to share a ton of information between those workers. We're talking about sending all those learned parameters, and that can still require a huge amount of bandwidth.
Ah, the infamous bandwidth bottleneck. So how do we get around that? That's where streaming DeLoco comes in, right?
You got it. Streaming DeLoco is the real star of this paper, and it basically introduces three main innovations to tackle that bottleneck.
Three innovations. Okay, lay them on me.
So, first up, we have a change in how the data is synchronized. Instead of sending all those learned parameters all at once, they get broken down into smaller pieces called fragments and synchronized sequentially.
Hmm, I see. So instead of trying to cram all those puzzle pieces through the door at once, we're sending them through one by one in an organized way.
Exactly.
Absurd.
Much more manageable, right? Now, the second innovation is about overlapping communication with computation.
Overlapping. What do you mean by that?
It means the workers don't have to just sit there twiddling their thumbs while waiting for the synchronization to finish. They can actually keep training on the next batch of data while the previous fragment is being shared.
Ah, multitasking.
Mm,
Clever. They're making the most of their time.
right. Efficiency is key here. Okay, and the third innovation is all about compressing the information that needs to be shared.
Compression. So like zipping up a file to make it smaller?
Kind of. It's more like using shorthand to make those instructions more concise. Technically, it's called quantization, and it uses lower precision numbers to represent the information.
Okay, so they're streamlining the communication without losing any of the essential information. Sounds like a win-win to me.
Okay.
But does all of this actually work? Does streaming DeLoco deliver?
Well, the researchers put it to the test, running simulations to see how it performed, and guess what?
It was a smashing success.
You could say that. They found that streaming DeLoco significantly improved what's called compute utilization. Basically, those powerful computers spend more time actually doing the training and less time just waiting around for information to be shared.
Now that's what I like to hear, making those expensive computers earn their keep. But did they just do simulations, or did they try this out with real language models?
Oh, they definitely put it to the test in the real world. They ran experiments using actual large language models and found that streaming DeLoco could achieve the same level of performance as traditional methods, but using way less bandwidth.
Hold on, so you're telling me we could potentially train these super powerful AI models on like a regular internet connection?
Potentially, yes. It really could be a game changer for researchers who don't have access to those crazy fast networks.
It's blowing my mind. And it gets even better.
Oh, yeah, there's more. They even tested it out on this massive data set called DOLMA and found that in some cases, streaming DeLoco actually outperformed the traditional methods.
What? So it's not only more efficient, but it can be more effective too. Tell me more about these DOLMA results.
Well, they trained this 1 billion parameter model on a massive scale, like up to 250 billion tokens. It's a truly enormous amount of data.
Wow, 250 billion tokens. That's just mind-boggling. And streaming DeLoco handled it.
Like a champ. It
Yeah.
matched the accuracy of those traditional methods on benchmark tasks like HelloSwag, Pika, and ArcEasy, all that. and using a fraction of the bandwidth.
Okay, that's impressive. But just how much bandwidth did they save? Give me some numbers.
We're talking about a 400 times reduction in overall bandwidth usage. And the bursts of communication were reduced by a factor of 8.
Whoa, 400 times? That's incredible. And remember that overlapping thing we talked about earlier? That means the system is super tolerant to delays in communication.
Right. Even if communication takes a few seconds at this scale, it can just keep chugging along.
This is starting to sound a lot like that distributed free lunch promised in the paper's title. But, there's always a but. What are the caveats here?
Yeah, you're right to be cautious. It's important to remember that this is still early stage research, and there are definitely some things to consider.
Like what? What are the next steps? What needs more investigation?
One big question is scalability. Can we apply this approach to even larger models, the ones with potentially trillions of parameters that are on the horizon?
Okay, yeah, I can see that being a challenge. Scaling things up always brings new hurdles.
Definitely. And another thing to explore is how streaming DiLoCo performs with more complex training scenarios. The experiments in this paper focused on a specific type of model and data set, but the real world is messy.
Right, there's a whole universe of different models and data sets out there. We need to make sure streaming DeLoco is versatile enough to handle all of them.
Absolutely. And then there's the question of memory overhead. Streaming DiLoCo does require slightly more memory than traditional methods.
Yes, there's always a trade-off, isn't there? But didn't they mention a potential workaround in the paper? Something about using the CPU's memory?
Yes, they did. They suggested offloading some information onto the CPU memory, which is usually much larger than the specialized memory used for processing.
So it's like having a separate, bigger workspace to free up the main processing area. Clever. And speaking of clever, I was really intrigued by all those details in the paper about how they optimized streaming DeLoco, experimenting with different synchronization patterns and even different types of compression.
Oh yeah, there's a lot to unpack there. They really dug deep into the nitty-gritty. For example, they explored both sequential and strided patterns for synchronizing those model parameters.
So sequential is like sharing those puzzle pieces in order, and strided is like what, jumping ahead a few pieces at a time?
Exactly. And what they found was that the strided pattern actually led to slightly better compute utilization.
So jumping around a bit actually keeps things running more smoothly. Fascinating. What about the compression side of things? They didn't just randomly squash the data down, did they?
Not at all. They explored various compression schemes, comparing those lower precision numbers to techniques that actually drop certain values altogether. Surprisingly, they found that just lowering the precision using a format called E3M0, which only uses 4 bits per parameter, worked incredibly well.
Wow, only 4 bits. That's amazing. So they were able to simplify the communication without sacrificing performance. But what about those other approaches, the ones that involve dropping values altogether? Did those work?
They did try things like Fed dropout, DARE, and even top case selection, which keeps only the largest values. But those methods actually ended up hurting the model's performance.
So trying to be too selective backfired. Sometimes less is more, but sometimes you really do need all the information.
Exactly. It's all about finding the right balance.
Okay, so we've covered the innovations of streaming DeLoco, those impressive results, and even some of the nitty-gritty optimization details. I'm already feeling like I understand this complex world a bit better.
Me too. And we're just getting started. There's so much more to uncover about how streaming DiLoCo fits within the larger landscape of distributed training and AI research as a whole.
Now that's what I like to hear. Context is key, and I can't wait to explore the bigger picture. But for now, let's take a quick pause. When we come back, we'll continue our deep dive into the fascinating world of streaming DeLoco and the future of distributed AI.
Welcome back. Before the pause, we were talking about streaming DiLoCo and its potential to really democratize AI. And, it's not just about giving more people access to the tools. It's about building this whole new ecosystem for AI development.
Yeah, it sounds like you're picturing a much more connected and collaborative approach to AI research, which I love.
Absolutely. Imagine this global network of researchers all contributing their unique insights and expertise to really push AI forward. With streaming DiLoCo, those limitations of geographical boundaries and limited resources, they wouldn't be such a roadblock.
It's a pretty inspiring thought, a global AI brain trust working together to benefit everyone. But of course, we have to tackle those practical challenges first. So where do we even begin?
Well, one area that's really exciting is exploring even better compression techniques. Remember how streaming DeLoco uses that E3M0 format to shrink down the amount of data that needs to be shared?
Yeah, the shorthand for those model parameters, it worked amazingly well in those experiments. But I'm guessing there's always room for improvement.
Oh, for sure. Researchers are always coming up with new and improved compression algorithms. Some of them even leverage the structure of deep learning models themselves to find even more efficient ways to represent that information.
So it's like finding the most elegant way to summarize those complex concepts without losing any of the core meaning.
You got it. And the more we can compress that data, the less bandwidth we need. And that makes it even easier to distribute the training process across like tons of devices.
Makes sense. But what about that challenge of heterogeneity we touched on earlier? How can we make sure streaming DeLoco can handle all those different types of hardware and internet connections out there in the wild?
That's where robustness comes in. We need to develop algorithms that can handle those variations in the training environment. One way to do that is by creating these flexible synchronization schemes that can adapt to the speeds and capabilities of each individual worker.
So instead of forcing everyone to march to the beat of the same drum, we let each worker work at their own pace and just synchronize when they're ready.
Exactly. And it might even involve dynamically allocating resources based on each worker's capabilities. We need to build as much flexibility and adaptability into the system as we can.
Okay, yeah, that's really smart. This is all sounding super promising. But I can't help but think about some of the potential downsides of this whole collaborative approach to AI development. I mean, could we lose control? Could there be new security risks we haven't even thought of?
Those are valid concerns, and they really underscore the need for responsible AI development from the very beginning. One of the risks is that someone could intentionally inject biased or harmful data into the training process.
Ugh, that's a scary thought. Someone deliberately trying to corrupt the data and skew the results. How do we prevent something like that from happening?
Well, researchers are definitely working on ways to address that. One promising approach is developing ways to verify the integrity of the training data. Think of it like a super rigorous fact-checking process, but for data.
That makes a lot of sense. We need to make sure we're training these AI models on accurate and reliable information. But what about the issue of control in this kind of decentralized system? How do we even make sure the AI we're creating aligns with, like, our values and goals if there are so many different people contributing to its training?
That's where governance comes in, which is basically about creating clear guidelines and mechanisms to oversee the whole training process. It's about making sure everything aligns with ethical principles and societal values. Think of it like setting up a framework for responsible collaboration.
Okay, so like having a shared set of principles and ground rules that everyone agrees to follow.
Exactly. And it might also involve developing methods for auditing the models after they've been trained, to make sure they're not exhibiting any biases or unintended consequences.
Yeah, that's super important. Sometimes I get a little overwhelmed by how complex all of this is. Do you ever feel that way?
Oh, absolutely. AI is an incredibly complex field, but I try to keep my focus on the potential benefits. Imagine if we could use AI to solve some of humanity's toughest challenges, like climate change or disease eradication.
Now, those are visions worth getting excited about. It makes all those challenges we've been talking about seem, well, less daunting.
Exactly. It's crucial to remember that we're not just passive bystanders in this whole technological revolution. We actually have the power to shape it, to steer it toward positive outcomes.
Okay, I love that. You've given me a renewed sense of hope. But to really make a difference, we need to understand all the details. So let's dive back into streaming DeLoco for a bit. You mentioned those different synchronization patterns, the sequential versus the strided approach.
Right. Remember we talked about sequential being like sharing notes page by page, while strided is more like jumping ahead a few pages at a time. And they found that strided worked better, but I bet you're wondering why.
Oh, I definitely am. It seems a bit counterintuitive that jumping around like that would be more efficient.
Well, it all comes down to how the different layers in a deep learning model interact with each other. Think of a model like a network, right? A network of interconnected nodes that are organized into layers. And each layer performs a specific computation, with the output of one layer becoming the input for the next one.
Okay, so it's like this multi-stage process where each stage builds on the work done by the previous one.
A perfect analogy. And in the case of language models, these layers are essentially extracting increasingly abstract and complex representations of language from the raw data.
Okay, so far so good. I'm following along.
Yeah.
But how does this all tie back to those synchronization patterns?
Well, you see the earlier layers in the model, they tend to learn these more general features of the data, while the later layers, they're more focused on learning specific task-related features.
Ah, I see. So it's like the early stages are laying the groundwork, and the later stages are adding the more refined details.
Exactly. And when you synchronize sequentially, you're making those later layers wait for the earlier ones to finish up before they can do anything. And that creates a bottleneck.
Ah, so those poor later layers are just sitting there idle, waiting for the earlier layers to catch up.
Exactly. But with the strided pattern, you're synchronizing those interleaved blocks. So those later layers get updates more frequently.
So you're giving them a head start, letting them work in parallel with the earlier layers?
That's it.
Yeah.
And that's why it's more efficient. It keeps all those worker nodes busy and minimizes that downtime.
Okay, that makes a lot of sense. I'm really starting to understand the nuances of these different approaches. Now, what about those compression techniques? We talked about how just lowering the precision of the numbers worked surprisingly well, but why didn't those other approaches, like dropping certain values altogether, perform as well?
That's a great question. It really highlights that balance between efficiency and accuracy in deep learning. See, when you drop values, you're essentially throwing away information. And that can really hurt the model's ability to learn effectively.
So it's like ripping pages out of a textbook. Sure, you'll save space, but you might be losing crucial information.
Precisely. Now, it might seem counterintuitive that lowering the precision doesn't have that same negative effect. But here's the thing. Deep learning models are incredibly tolerant to noise and imprecision in the parameters.
So they can see the forest for the trees, focusing on the overall patterns instead of getting hung up on those tiny details.
Exactly. They rely on the relationships between the values, not necessarily the precise individual values themselves. And that's why lowering the precision can be such an effective way to compress the data without really impacting performance.
Okay, that makes a lot of sense. But is there a limit to how much we can compress the data before it actually starts to affect the accuracy?
That's something researchers are actively investigating. The optimal level of compression, it's likely to depend on a whole bunch of factors. Things like the size and complexity of the model, the training data, and the level of accuracy you're aiming for. It's about finding that sweet spot for each specific situation.
Okay, so there's no magic formula, no one-size-fits-all solution. It's more about tailoring the approach to fit the unique needs of the task at hand.
You got it. And that's one of the things that makes this research so exciting. It's pushing the boundaries of our understanding of deep learning and opening up all these new avenues for optimization and improvement.
I love it. I'm so curious to see where all of this research leads. But before we get too far ahead of ourselves, let's bring it back down to earth for a bit and talk about the real-world implications of streaming DiLoCo. We've talked a lot about how it could democratize AI, but can you give me some concrete examples of how this technology could be used to solve some real-world problems?
Sure. One area where streaming DiLoCo could have a huge impact is personalized medicine. Imagine being able to train AI models on massive data sets of genetic information, medical records, and lifestyle data to develop super individualized treatments for people.
So like having an AI doctor that can analyze your unique health profile and recommend the best course of action, that's incredible. But wouldn't that involve sharing tons of very sensitive medical data across a whole network of devices?
You're right, which is why those privacy-preserving features of federated learning are so important here. Remember, with federated learning, you can actually train models on data that's distributed across all those devices without ever having to bring it all together in one central location.
Right, it's like those puzzle teams again. Each one working with their own set of pieces and only sharing their findings without revealing the individual pieces themselves.
Exactly, and that means we can train these powerful AI models on sensitive data without compromising people's privacy.
That's a total game changer, especially for healthcare. Are there any other areas where you see streaming DiLoCo having a major impact?
Oh, absolutely. Another area is climate science. We could train AI models on huge amounts of climate data, like satellite images, sensor readings, you name it, and use those models to create more accurate climate predictions. Imagine being able to predict extreme weather events with much greater precision.
Wow, so we could have AI meteorologists that give us better warnings about hurricanes, floods, droughts, all those things.
Exactly. And because we could distribute the training process across such a vast network, We can analyze these huge and super complex data sets, which should lead to more reliable predictions.
Wow. Okay, so we have personalized medicine, climate science. It sounds like streaming DeLoco has the potential to really revolutionize almost every field imaginable. But what about the potential societal impact? I mean, could it make existing inequalities even worse? Could it lead to job displacement? These are things we need to think about.
You're right. Those are really important questions to consider. And they underscore the need for a thoughtful and responsible approach to AI development right from the start. Like any powerful technology, AI can be used for good or for bad. And ultimately, the outcome depends on the choices we make as a society.
So it's not really about the technology itself, but more about how we choose to use it. Our values and intentions shape the impact it'll have.
Exactly. And that's why it's so important to have these open and honest conversations about the ethical implications of AI, to establish clear guidelines, and to make sure that the development of AI is always aligned with human values and goals.
You've given me so much to think about. It's incredibly exciting to explore all the potential of this technology, but I think it's crucial to proceed with caution and ask those hard questions along the way.
I couldn't agree more. One of the most important roles we have as researchers and developers is to not just push the technological boundaries, but to actively engage in open dialogues about the potential consequences of our work.
It's about shaping the conversation around AI and making sure it truly serves humanity.
Precisely.
Okay, well said. I'm feeling super inspired and ready to dive even deeper, but I know our listeners are probably eager to hear about all the latest developments in streaming DeLoco and related research. So before we wrap up this part of our discussion, I want to remind everyone to check out the show notes. We've got links to the research paper and a ton of other awesome resources.
Yes, there's so much to explore.
We'll be back after a short break to continue our deep dive into this exciting world of streaming DeLoco and the future of distributed AI. Stay tuned. And we're back for the final part of our deep dive into streaming DeLoco. Before the break, we were talking about all the potential societal impacts, how it could change the whole landscape of AI research and development.
Yeah, we were discussing that shift towards a more collaborative approach
Yeah.
and how this technology could really empower individuals and smaller organizations that maybe don't have those massive resources.
Right, giving everyone a seat at the table. But I imagine this shift won't happen overnight. There are going to be some bumps in the road. What kind of obstacles do you think we might encounter along the way?
Well, I think one of the biggest challenges is going to be overcoming that kind of inertia in the research community. Like we were saying before, there's this huge emphasis on individual achievement, on publishing in those top conferences. And that can sometimes make collaboration, well, a little less appealing.
Yeah, I get it. Everyone's so focused on being the best, the first, the most cited that they kind of forget about the power of teamwork.
Exactly. So to really shift that mindset, I think we need a real concerted effort from everyone involved. I mean, what if funding agencies started prioritizing projects that involve collaboration across different institutions and disciplines?
So, rewarding teamwork over individual brilliance. I like the sound of that. What else could we do?
Well, what about academic journals? What if they started placing more value on research that focuses on tackling real-world problems, even if it doesn't necessarily lead to, like, major theoretical breakthroughs?
It's about recognizing that impact doesn't always have to come in the form of a fancy equation or a groundbreaking theorem. Sometimes the most valuable research is the kind that actually makes a difference in people's lives.
Exactly. And I think the AI community itself has a huge role to play here, too.
How so?
Well, we need to cultivate a culture of mentorship and knowledge sharing. Create an environment where everyone feels valued and supported no matter what their background is or what kind of resources they have access to.
Okay, so it's about building a more inclusive and supportive community, one where everyone can learn from each other and grow together. I love that. But what about the more practical challenges of actually using streaming DeLoco? Are there any hurdles that researchers or developers might encounter on that front?
Oh, definitely. I mean, one of the biggest things is going to be developing the tools and platforms that make it really easy for people to collaborate on training and deploying these AI models.
So it's about creating the infrastructure to support this new way of working, right? Making it user-friendly and accessible to everyone.
Absolutely. We need those intuitive interfaces and workflows that abstract away all that complexity of distributed training and make it something that anyone can use, even if they're not a computer science whiz.
Yeah, focusing on user experience is key. But what about the technical side of things? Are there any areas where streaming DeLoco itself needs to be improved or adapted to make this vision a reality?
Well, yeah, there are still some technical challenges to tackle. Remember, we were talking about that memory overhead issue earlier.
Right, that streaming DeLoco needs a bit more memory than those traditional methods. And while offloading some of that information to the CPU memory is a helpful workaround, it's not a perfect solution.
You got it. So researchers are exploring ways to maybe compress the model itself and optimize those algorithms to make them use less memory overall.
So it's like how we're always trying to find new ways to improve our own brains, learning new techniques to boost our memory and processing speed.
Uh-huh. Yeah, that's a great analogy. And another big area of focus is developing methods for handling different types of data. A lot of the current research has focused on text data, but in the real world, we're dealing with images, audio, sensor readings, all sorts of things.
Yeah, that's a great point. We need to make sure streaming DeLoco can handle that full spectrum of data that's out there in the wild, not just text.
Exactly. And that means developing new algorithms and techniques that are specifically designed to work with those different types of data and all their unique characteristics. It's definitely a big challenge, but it's also an incredibly exciting one.
I love it. So many possibilities. But, before we wrap things up completely, I have to ask kind of a philosophical question. We've talked a lot about the technical details and the potential benefits of streaming DeLoco, but what does the rise of this distributed collaborative AI really mean for humanity? Does it change who we are? Does it change how we interact with the world?
Whoa, that's a deep one. I think AI has this incredible potential to kind of amplify both the best and the worst aspects of human nature. It can be a powerful tool for good, but it can also be misused and lead to negative outcomes. And I truly believe that the ultimate impact of AI, it really depends on the choices we make as a society.
So it's not about the technology itself, but about how we choose to use it. Our values and our intentions really determine the course of its development and its impact on the world.
Exactly. And that's why it's so crucial to have these open and honest conversations about the ethical implications of AI, to set clear guidelines for its development, and to make sure that everything we do with AI aligns with our values and our goals as a species.
Yeah, I couldn't agree more. It really feels like we're at a crossroads. And the choices we make now are going to have a huge impact on the future, not just of AI, but of humanity as a whole.
I think so too. We need to be thoughtful and responsible in how we approach this technology. But I'm also optimistic. I think AI has the potential to help us create a better world for everyone.
I love that. It's not just about the technical advancements themselves, but about what we choose to do with them. It's about using our collective intelligence, our ingenuity, to solve those big problems and improve lives.
Well said. It's about the journey as much as the destination.
That's a perfect note to end on. It's not just about reaching some far-off goal, but about the steps we take along the way and the values that guide us. Well, thank you so much for joining me on this deep dive into streaming DeLoco and the future of distributed AI. It's been a fascinating conversation.
The pleasure was all mine. I always enjoy getting to explore these ideas with you.
And to all our listeners out there, thank you so much for joining us on this incredible journey of discovery. We hope this deep dive has given you a fresh perspective on the potential of AI and all the challenges and opportunities that lie ahead. We'll be back next time with another deep dive into a cutting edge topic. Until then, stay curious.